a log function is and deal with those. And today what we're going to do is graph them, and we're going to learn how to write them and how to read them, and we're going to solve easy ones. And then as we progress tomorrow, we're going to kind of kick it up a notch, and we're going to talk about the properties that logs have. Just like regular equations, they have properties. You can add, subtract, multiply, divide, all that stuff. And then, let's see, that's tomorrow's Thursday. So then when we come around to Monday, we'll finish out the unit, and we will be doing some, if we start out here, we're going to kind of kick it up a notch each day. And so by the time we reach next Monday, we'll have finished it. And then we'll have Tuesday to kind of practice some problems, ask your questions. Then Wednesday will be the official review. And then Thursday and into Friday will be the exam. So we're just moving right along. And so then after next week, we'll have 1 week of review for the final, where you'll be able to ask me questions and whatnot. Also, you'll be able to do your replacement exam. And then we'll take the final, and then that'll be it. Okay? So any questions on the plan for the rest of the semester? Okay, so give me a second here to get my whiteboard up, and then we will go ahead and get started. And if you happen to have noticed, I was on the ball yesterday, and I got the notes for this section and next section done already. So, okay. All right, so where am I going to start? Okay, so here we go. Like I said, this is 7.3. In this section, talk about logs and their functions. And how many of you, I'm scared to ask this question, but how many of you have worked with logs in the past?
I did in high school.
Okay, so some people have, so unless you really enjoyed what you did, I want you to pretend like this is brand spanking new to you, okay? Because I have an approach that people have said to me, oh, this is way better than I did in high school. So my fingers are crossed that if you ever have worked with logs, you can kind of just say, okay, well, maybe I didn't love them then, but I'll give it a shot. All right, so here we go. As always, pause me if you need to, stop me, do something. So this is 7.3, log functions and graphs. And I mentioned the other day that I was going to stop writing out the word exponential and just write it as expo. Instead of writing logarithm every single time, I'm just going to write log. Okay, so when you see me write the word log, you know what I'm talking about. Okay, so the first thing that we need to talk about is what is a logarithm function? Okay, because we've never talked about that in this class. So here's the actual whole entire word. Logarithmic functions, aka logs, okay? And so here's the definition. The log function with base a, and remember for right now, this is not the word a, okay, it's a variable, so I'm going to put it in these little quotes, is the inverse of the expo function that we looked at the other day, a to the x. So when we talk about an exponential function, we did this, Monday, I guess? We said the expo function was a to the x. And so what we're going to say is when we talk about the log function, that's going to be the inverse. And when we did the inverses, what did we do? We picked up the x and then we picked up the y, and we swapped them, so to speak. So this is what we got to know. Okay, so we're going to say, so if f of x equals a to the x, which is, not a squared, a to the x, which is just the expo function. So underneath of it, I'm going to write expo. That's just the exponential function that we studied the other day. Then, if that's the case, f inverse of x is going to equal log base a of x. Now write this down first, and then we have to talk about how to read these things, because if we can't read them, we can't solve them. Okay, so take just a sec, jot that down. Okay, we know already some of this information. When we studied inverses several days ago, I've lost all track of time, okay? We know for sure that this is how we write inverse, okay? We don't say f of -1 or anything crazy. We literally say f inverse, and then we say of, and then we say x, f inverse of x. Okay, that's not new. Here's what's new. This form. Here's how we read it. We say log base, and then whatever this is, whether it's a variable or a number, that's our base. So in this particular instance, we're going to read this as log base A, and then of x. So this is log base A of x. And this A and this x will change. Sometimes they're numbers, sometimes they're letters. It just depends on the problem. But as a whole, we read this as f inverse of x equals log base A of x. Now, before I go any further, are there any questions on just what this says? Okay, not necessarily what it means, because we haven't really had a chance to do that, but just on what it says. Okay. So, move on to the next line, because I got a few other things to tell you, and then we'll take a look at some problems. So on the next thing, I'm going to write a sentence. We're going to say, okay, this is another important thing, that x equals a to the y, and y equals log base A of x are equivalent. This is going to help us later on. They're equivalent, okay? A is the base in both. Okay, so what that means is, if you look right here, we have studied exponents in the past. We know that this, let me make this look more like an A, because right now it looks like a 9. We know that this letter, or whatever this number happens to be, whether it's a letter or number, this is the base. And we just learned that whatever this is the base. Notice that it's exactly the same, okay? And so what's going to happen is we're going to use these two pieces later on, kind of interchangeably, so to speak, because they're the same thing. They are equivalent. Okay, now, what are your thoughts on that? Now, I know you haven't had a chance to look, and I'm about to show you, so maybe you let me show you an example first, and then you ask. Okay, so we're going to dive right into some problems, and we'll do example 1 right here, right now. And so what I'm trying to do, okay, actually, I don't want to write that yet. What I am going to ask us to do is we are going to go from, we have to be able to write these things very easily, from an exponential function to a log function. In other words, whatever we're given, quickly find its inverse, and we got to be able to do this pretty quick. Okay, so here's the first one. If we say 2 to the third equals 8, right now this is an exponential function. So underneath of it, I'm going to write expo. I need you and me to figure out how the heck we're going to write this as a log function. If you had to guess, based on the stuff written above, what would we write? How would we do this? Anybody remember, or anybody know, or anybody understand what I'm even trying to say?
Make the bases the same.
Okay, so the bases are going to be the same. All right, and what else? So what I'm asking you to do, and I'm going to erase this in just a moment, is give me something that looks like this, out of this. That's what I'm asking you to do. So if you take a look at this, okay, right now, the formula that we're given is in this form. It's a little bit backward, but that's okay. So in this case, the base is the number 3, very close, okay? Let's see, log 2. Actually, that is correct. It's just hard for me to read like that, but yeah, you're right. So watch what we're gonna do, okay? There's a lot of information here, and I don't want you guys to have to spend 25 minutes trying to figure this out. So here's the shortcut that we're gonna do every single time, okay? And if you love it, awesome, and if you hate it, you're gonna have to learn to love it. Okay, watch. We're gonna start at our base every single time. We're going to draw an arrow to whatever this is. And then we're going to pick up, we're going to skip over that 8, we're going to pick up, and then we're going to hit the last number that we haven't hit. And basically what we're doing is we're kind of making a circle, okay? And so then what's going to happen is once we draw these arrows, every single time they're going to work that same exact way. We're going to write the word log. Then we started with our base of 2, so base 2. And then when we drew our arrow, it went to the number 8. And so we're going to say, okay, of 8. And then look what happens to this arrow. It crosses the equal sign. So which tells me I need to put an equal sign. And then where do I land? Just the number 3. And just like that, without having to do any real work, I'm done. I've written this from an exponential function. I've gone from an exponential function to a log function. What are your thoughts on that one?
So how do we put that in our calculator?
Oh, you don't. That's the thing about logs. There's a lot of the times we can't use our calculator, which is why we have to memorize this process. But realistically speaking, how difficult was it for me to draw these arrows? That was a piece of cake, right?
Extremely easy.
Extremely easy. And so once I draw the,
Suspiciously easy.
oh, no. So once
Very suspicious.
no, you guys. Think about it though. Look, I was given the number 2. That was the first number I was given. 2 is the first number I wrote. I scooped over here to 8. 8 was the second number I wrote. I crossed the equal sign. The equal sign came next. I ended on this 3. I ended on this 3. That's it. Everything is taken care of. The only thing I've done is I've gone from the exponential form to the log form. And that's it. I'm done. I'm not trying to tease you. This is it. It's this straightforward. I don't know why logs have such a bad rap. All right, let's try a few more just to prove to you that I'm not full of BS, okay? All right, so here we go. So that was example 1. Let's take a look at example 2. We're going to have 5 to the 4th equals 625. And this is an exponential function, and I want a log function. So again, I'm going to get my marker out here. And where is my pen going to start? I want to draw these arrows. That's what's going to save your life, are these arrows. Where does my pen need to start?
The 5
5.
Where does my pen go?
to 625.
And I stop, and I come down below the 625. And now where do I go?
4 to
4.
the 4.
And so now I'm ready to actually write the function because I drew the picture. And so I write the word log because that's where I'm trying to end. What's my base?
5.
5. I go from 5 to which number?
625.
Then I cross the equal sign, and where do I end? Where do I end?
4.
Okay, done.
So is it log 5 and then you raise it to 625?
No. So this little guy right here, and if these are just regular old numbers, normal size.
Okay.
This little guy right here is teeny tiny, and we call that base. So we read this as log base 5 of 625 equals 4.
Okay.
Okay, so whatever this teeny tiny number is, we always say base. Okay. All right, let's take a look at one more, and then we'll have to go the opposite direction. Okay, and it's just as easy. So here's number 3, and this one's going to have just some letters in it to prove to you that it's the same every time. So there's some numbers and there's some letters. Well, this is given to us in exponential form. I need you to give it to me in log form. So I draw my arrows. Where do I start?
7,
Where do I go?
C,
And I start from Z and I go,
X,
okay. And so then I say, all right, well, I drew my arrows. And I say, okay, I start with the word log because I know that's where I'm headed. And my base is,
7,
and my big letter or number here is,
Z,
and then I'm my equal sign, and where do I end? It's that easy, guys. You got it. What do you think?
How do we type the 5 and the 7 into hawks?
Okay, so what's going to happen is when you go to type this, like if you're typing this in, you're going to have your keypad that you use sometimes. You know what I'm talking about?
Yes.
Okay, and there's going to be a button that says LOG. And if you click that button, LOG, the word LOG is going to pop up. There's going to be a blank space here, a blank space here, an equal sign, and a blank space here. And you'll just
Okay.
type the 7, the Z, and the Y, or whatever, the X, and then that'll be it.
Okay.
But you have to hit this log button first. You can't just type 7XZ. That doesn't work. You have to hit the button first. Okay? All right, so not so bad, right? So far, so good. See, you guys think I'm crazy, but I know things. Okay, now, in addition to be able to go from expo to log, we have to be able to do that in reverse, and we have to be able to do it just as easily. Okay, so here's what's going to happen. The next thing that we're going to do is we're going to be able to go from log to expo. Sometimes I need a log function. I need it written as an exponential function because it makes it easier to solve. So let's take a look. So here's example 4. What if I give you log base 3 of 9 equals 2? So I'm giving it to you in log form. I want you to give it to me in expo form. Oh gosh. Okay, well, what's our base?
3
And then where do you think my pen's going to go?
2,
To the 2.
And then where do you think my pen's going to go?
To the 9.
Isn't that the same exact shape that we just drew? Yeah. And so what's going to happen is we're going to say, okay, well, when we go from log to expo, we don't want the word log anymore. And so our base is the number 3. We're saying, oh, we're going to put it to the second power. We cross that equal sign, and then it's 9. Is this a true statement? Is 3 squared 9?
Yes.
Isn't that cool? Is that better than anything you've ever seen in your life, or what? All right, now we're going to do a few more like this, okay? But this isn't that bad, okay? I don't know what you guys learned back in the day when you hate these things, but I actually really like logs a lot. Okay, I think they're pretty cool. All right, so let's try another one. So what if I gave you log base 8 of 512 equals 3? So where does my pen start? Yeah, your teacher's overcomplicated. Yeah. Listen, you guys, I don't think I ever really told you this, but I used to not necessarily be the best math student, and so I had to work my butt off in college. And so I learned ways to understand things when people who were way smarter than me were overcomplicating it. And so I'm able to break it down for you guys like I needed someone to break it down for me, okay? So where is my pen going to start?
8.
8
And where's it going to go?
to the 30
3.
And where's it going to go from there?
to the 512.
So what's my my log, or excuse me, my goodness, what's my expo function going to look like?
8 to the 3rd equals 512.
Now, is that a true statement? Yeah.
Yes.
All right, one more, and this time you guys do it without me. How about this? How about log base 2 of x equals y? And again, there's letters and there's numbers just to prove to you that this works. So where does my pen start and where does it end?
2 to the y equals x.
See? You guys got it already. It's been like 5 minutes. All right, now, before we move on, because now what we're going to do is we're going to graph these things. Okay, and I want your brain to think back to the other day when we graphed our exponential functions. Okay, so don't write this, just watch for a second. That's when we had something that looked like this. We had maybe f of x equals, I don't know, 1/2 to the x. Remember we did that? And we said, oh, in this case, the a is 1/2. And since it's 1/2, that's less than 1, so my function is decreasing. Remember us doing that? And we said that the point on my y-axis was 0, 1. It was the y-intercept. Okay, well, watch what's about to happen. Okay, so what we're going to do is we're going to learn and we're going to talk about how to graph log functions. Okay, and believe it or not, you already know how to do some of this. I keep spelling the word graph wrong because there's a lot of information that we talked about the other day. So here's what I want you to do. I want you to think back for a moment, okay? I want you to recall, I love that word, recall that, okay, the graphs, you have to dig back to 2 days ago, of a function and its inverse are reflections of each other, and then I'm going to draw a picture too, okay? Of each other with respect to the line y equals x. Okay, so let me draw a picture and show you what that means. Hold on, I messed up. So this dotted line is the line y equals x. Okay, and so this sentence says the graph of a function. So let's say that we have f of x will be red, let's just say, and then in blue we'll have f inverse of x because that's its inverse. And let's pretend for just a second that f of x looks something like this. And I'm just making this up totally, okay? Literally just to show you a picture. Let's say that's what f of x looks like, okay? Well, if we were to calculate its inverse, when we first talked about inverses way back, we know that we just switch the x and the y. Remember, it was super easy. And so if I have the point x comma y on the red graph on my f of x, that means that over here on the inverse, I'm going to have the point yx. And so without actually having to do any work, what's happening is this line, y equals x, that's like a mirror. If I could pick this up and fold it along this dotted line, just like we did with our palms the other day, then whatever's over here is going to mirror perfectly on the other side. And so what that means is the inverse would look something like that. They're just reflections of each other. Okay, so if you're having a hard time visualizing it, hold your hands up in front of you with just your palms facing you, and let the side of your hands where your pinkies are touch. And pretend that's the graph. If you fold your palms perfectly in half, they're going to match up perfectly. That's what these two lines would be doing if I could fold it across that line. So what's going to happen is we're going to use all the information that we know how to graph something that looks like this, f of x equals a to the x. And we're going to call that our f of x. And then in order to find our inverse, we know that that's the log function. And so we already know how to graph these guys. And so with just a teeny tiny bit of new information, we'll be able to graph the log, okay? So let me write a few more pieces of information down and then we'll do it. So here's some information that we just need to be aware of, okay? We already know from our notes that logs are the inverse. Logs are the inverses of exponential functions. We talked about that already. We just learned that in our notes. Okay? That's the first thing that we need to know. So we go on to say, so the y-intercept of the expo was 0, 1. Okay, remember how we did that? Every time we started at 0, 1 and we either increased or we decreased. That was our expo. What's going to happen is this is now going to becomes, we're going to switch the x and the y. So we're going to literally pick this up and we're going to switch it. So it's going to become the point 1, 0, which is x-intercept for the log function. So we're going to take this 1, 0, and it's going to become my x-intercept. So now, instead of having the point at 0, 1, now I have a point over here. And so what's going to happen is my graph is either going to be decreasing or it's going to be increasing. So it's going to look similar. It's just going to be on the other side of the graph. Okay? Let me see what's going on in the chat.
I think it's actually you, Amanda. I don't think it's anyone. I think whenever you're writing, I think you're hitting something. And
Oh, I bet you're probably right. All right, let me just make one slight change. That could be it. Does that sound better, guys?
Yes, thank you.
Okay. Yeah, guys, just tell me, because if you don't tell me, I don't know. Okay. I'm sorry, Heather. Okay. All right. So let's go ahead, and there's just a few more things that I want to tell you, and then we'll finally get to look at a picture. Okay. So the logs are inverses of exponential functions. The y-intercept of the expo that we did have, which was 0, 1, now we're going to flip it, and where it's going to become 1, 0. And now instead of being a y-intercept, it's going to be an x-intercept. Okay. So there's a few more things I want to tell you real quick, and then we will do it. So we're going to say that if the log base, and this is not the word a, okay, it's just the base, is less than 1, it's still decreasing, just like it was the other day. It's still decreasing, but through the point 1, 0. Okay. On the other hand, if the log base a is greater than 1, it's increasing through the point 1, 0. So this is the new piece of information. It's just that our point has changed. Okay. And then the last piece of information before we actually give it a shot is, instead of picking, does anybody remember what x values we chose last time?
-1, 0, and 1.
Absolutely. So instead of picking x to equal -1, 0, and 1, what happens? We're going to switch the x and the y. So we will pick the y value
To be -1, 0, 1.
Exactly. Yep. Okay, because literally that's all we're doing. We're switching the x's and the y's. That's it. Okay, so if the log base that we're given is less than 1, guess what? It's still a decreasing function. It just goes through a different point. If the log base is greater than 1, guess what? It's still an increasing function. It just goes to that same different point. And when we make our x and y chart, instead of us picking the x values to be -1, 0, and 1, we're just going to swap over and pick the y values. So that's going to be the main difference. So now, take that in for a second. We're ready to take a look and see what happens, okay? And we're just going to look at 2 because they're so similar. Actually, I lied. We'll look at 3 because they're similar to what we did, so you probably already have kind of a good idea. All right, so any questions before I put up a picture and we actually graph this thing? All right, so this is example 7. And the problem is f of x equals log base 3 of x. And so what I'd like to do is, before anything else, I want to go ahead and write this thing in a way that I can No, let me back it up. What I want to do is I want to identify the base. Okay. And so if this is my function and I say, hey, I need you to graph this, what's the base of this function?
3.
Okay. So we're going to say the base, which is A equals 3. And then we're going to ask ourselves, just like we did last time, is 3 greater than 1 or less than 1?
Greater than.
Okay. So it's greater than 1. So we know right off the bat that this is an increasing function. So increasing. And we know that the x-intercept of the parent function is 1, 0. And so now what we're going to do is we're going to take a look up here and we're going to say, okay, up here where my function is, do I see any other transformations? Remember how we did that the other day? We talked about left, right, up, down, if there was an x-axis or y-axis reflection. Is anything else happening to this?
No.
No. So there's no other transformations. So no transformations. Okay, and so what's going to happen is we're ready to make our x and y chart. So here's my x, here's my y. Now, we just said on the previous page, we're not picking x's anymore, we're picking y's. But we're going to pick those same 3 numbers. And so what's going to happen is, I sure don't know how to put a 1 right here. I don't know how to do that, okay, because we haven't learned. So what we're going to do is we're just going to say, la, 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 we don't care about you. We're going to put equals y. And then we're going to draw our arrows, and we're going to quickly say, oh, this is really 3 to the y equals x. And now I don't really care about this guy as far as the calculating goes. This is what I need to use to plug in my information. Okay, so do you see why it's so important that we can quickly make that transition? Because we have to be able to say, oh, look, here's my function, really. So then I'm going to take each of these 3 little guys, and I'm going to pop them in right there.
So you just put it in expo form.
Yes. And you can even do that first if you want. It will not hurt you to do that first. Okay? And so we're going to have 3 to the negative 1, 3 to the 0, and 3 to the 1. Well, what is 3 to the negative 1?
-3.
Nope. Remember when we have...
0.
Nope. Remember when we have our exponents, we have our bookshelf, remember? And we say we're not allowed to have, yeah, it's 1/3. We're not allowed to have negative exponents on the top. So we literally pick this thing up and we swap it. And that's going to give me 1 over 3 to the positive 1, which is just 1/3. Okay, so now that's something else that we have to recall, very much so. Okay, we
Wouldn't it be negative 1/3 since it's...
No, because what happens is the whole idea of taking this, let's see, what is it? Hold on. The whole idea of taking this little guy, and right now he's over 1. I'm going to flip him completely upside down. The act of flipping turns my exponent positive.
Okay.
Okay, so we have to remember way, way back. Okay, so then what happens is eventually when we figure that out, and even if we want to use our calculator, we can. It's just sometimes we don't need to. Okay, so I try to encourage us to not use it. All right, so then next, what is 3 to the 0?
1.
Just 1. And what is 3 to the first power?
3.
3. And so now I have these 3 points. Okay, and so I will go over here to my graph, or I will make a graph even. And I'll say, okay, so 1, 2, 3, 4, something like this. Okay. And let's see. I'm going to graph the point 1/3, -1. So I'm going to start at 0, 0. I'm going to go over just a teensy tiny bit, and I'm going to go down to -1. Okay, so there's that one. And then I have to graph the point 1, 0, okay, which I knew was my x-intercept, so it better be there. And then I have to graph the point 3, 1. So I go over to the right 3, and I go up 1. And so we look back at our information, and we know it's supposed to be increasing. And so what's going to happen is I'm going to start way down here, and I'm going to bring my line up, and I'm going up, I'm going up, I'm going up, and I'm still going up. And now here's my log function, and I'm done. So from start to finish, what are your thoughts?
So it never touches the y-axis.
It never touches the y-axis. That is correct. Just like when we graph the exponential functions, if you remember, they never cross the x-axis. Well, what happens if we take the inverse? We switch the x and the y. And so the log function will, the parent function, okay? Now, there will be a time when maybe it will cross it, but the parent function, when there are no transformations, will not cross the y-axis. All right, so this is it, so to speak. This is the parent function. This information is pretty much the same that we were doing. This is the new piece. Okay, we picked the y values instead. We turned this into an exponential function, and then we graphed. Start to finish, what do you think?
Good.
It's not bad.
Yeah, it's not too bad. So let's do another one. But this one, I'm telling you, it's going to be decreasing, just so that you know. Okay. But obviously, I don't tell you that from the get-go every time. So let's take a look at example 8 here, and let's say, okay, what if I have g of x equals log base 1/2 of x? And again, I'm going to say graph. And so maybe this time, why don't we go ahead and write it as an exponential function first, just to get in the habit. Well, we know that way, way back, before we introduced function notation, we used to have a y. So it's okay if you just say, bye-bye function notation, here's my y. And then we know that we're going to draw our little arrows, and that's going to give me 1/2 to the y equals x. And this is the guy that I'm really focusing on when I'm doing my work. And so then I look at that and I say, okay, well, my base in this case is 1/2, and the number 1/2 less than 1. And so it is decreasing. And I know that the parent function, that its little x-axis, or my goodness, that its x-intercept is the point 1, 0. And we look back up at our log function and we say, okay, no other transformations are happening. And so there's no transformations. And so because of that, I'm ready to roll. So I'm going to pick my x, or excuse me, I'm going to make my x and my y chart. What are the y values that I'm choosing? So then I'm ready to take those y values and plug them in right here. And so I'm going to have 1/2 to the -1, 1/2 to the 0, and 1/2 to the first. Okay, so what do you think 1/2 to the -1 is? So think about this for 1 second. If this is what I have, 1/2 to the -1. Yeah, it's 2. Okay, it is 2. So what's going to happen is we had said we're not allowed to have negative exponents, and so we flip it. So in flipping that, that's going to give me 2/1 to the first, or just 2. So that's perfect. Excellent. Okay, so then what about the next one? What is 1/2 to the 0?
1.
Just 1. Okay, and then, oops, hold on, I've hit the wrong button. And then what is 1/2 to the first power?
Just 1/2.
Just 1/2. Okay, and so now I'm ready. And so I'll draw this thing out here. And again, when you're working in Hawks, the graphs will be much nicer. Okay, and you know my handwriting and my drawing ability, not great. Okay, so I'm going to start off by graphing the point 2, -1. So I'm going to go to the right 2, and I'm going to go down 1. Okay, and then I'm going to graph the x-intercept, which is 1, 0. So I go right 1, and I don't go anywhere else. And then lastly, I graph the point positive 1/2, 1. So I scooch over halfway, I go up 1. And I say, okay, well, according to the work that I previously did, I know this is a decreasing function, which means it just continues to go down. So I'm going to start at the top, and I'm going to draw my line down. And then I'm going to say, okay, ta-da, now I'm done. And so I've graphed a decreasing log function. What do you think?
Easy.
Yeah, not bad. All right, now, those two were very, very brief, very easy because there were no transformations happening, okay? And so what I want to do is I want to briefly talk about transformations, because there will be problems where the transformations do occur, just like they did when we had exponential. So let's take a look at one. Do we remember the transformations, or do I need to write that down again? Would you like to see those? Anybody?
Sure.
Okay, whoops, hold on. I don't want to write in purple. Oh, it didn't change. Okay, so let's say that we have f of x equals, and we'll just take a quick look at all the transformations that could happen, because we have to be aware of, if they are happening, what they mean. Okay, so even though we're talking about log, if we see a negative out here, what do you think that tells us? What has it always told us? X-axis reflection. REF, okay, good. And then the next thing is, oh, hey, if there happens to be a negative right in front of the x, what does that tell us?
Y-axis reflection.
Yep, y-axis reflection, perfect. And then we keep on moving and we say, oh, look, maybe there's a number right here. Well, if it's negative h, which direction am I going?
Right.
Mm-hmm. And if it's positive h, which direction am I going?
Left.
Perfect. And then if I see this guy, if it's plus k, I'm going
up.
And if it's minus k, I'm going
down.
Okay, so all of these still apply. Okay, so let's take a look at one where there is at least one transformation. In fact, there is going to be two here. So let's take a look and see. Okay, that way we can recognize them and we know how to deal with them. And it's not going to be as bad as maybe what you think. And this will be the last graph. Okay, so let's say we have g of x, and that equals log base 2 of negative x minus 1. Okay, so what we have to do, since this isn't just like log base 2 of x, we can't be drawing arrows, okay, because we got other stuff that we got to deal with. So unfortunately, we can't just draw the arrow and say, oh, look, it's an exponential form. So let's start out by saying the base is which number?
2.
2. And is 2 greater than 1 or less than 1? Well,
Greater.
it's greater. And so because of that, it's going to be what type of a function?
Increasing.
Okay. So then let's see. We know that the x-intercept is what? 1, 0? Okay, so what I'd like for you to do is take a second, look at this, and tell me what your transformations are. Okay, because we have to be able to look at that and say, well, here's one, and then here's another one. So what do these mean?
Y-axis reflection.
Okay, so let me get my purple one. So we have a y-axis reflection. Okay, and then what does this red one mean?
You're going right one.
Okay, now, right one. Somewhere in our notes the other day, I can't remember exactly when, but I had listed out the order in which we should do our transformations. And in case we can't remember, let me write them down real quick. It's left, right. There is no shrink or compress. So it's x-axis reflection, y-axis reflection, and then it's up, down. This is the order that we have to do these in. Okay. And so when I look at this, I need to know that which is going to happen first. I don't know why I didn't write that. Increasing. Which is going to happen first? Well, we go left to right. So we're going to go right one. So imagine, if you will, here's a graph. I'm at the point 1, 0. Where am I going to be if I go right one? What's my new point?
0, 0.
2, 0.
It's going to be 2, 0. Okay, hold on. My paper or
I
my
went
pen.
to the left.
Yeah. So here's what we're going to do. Okay. We're going to say I start at the point 1, 0. I'm going right 1, which is going to give me the point 1, 1. Okay. So we took care of that. Check. Now, if we do a y-axis reflection, so here's the y-axis. If I'm at the point 1, 1, let's say, and remember, it's mirrored across the y-axis through this line. So if I'm at the point 1, 1, hold on a second. I'm not at the point 1, 1. What am I doing? I'm at the point 2, 0. You guys, you got to keep me on my toes. Okay, I'm at the point 2, 0. If I pick this point up and I reflect it about this y-axis, what's this new point that I'm at over here?
-2, 0.
Okay, so if I start at 2, 0, and I do a y-axis reflection, then that puts me at the point -2, 0. Excellent. Okay, so now what's going to happen is I've taken care of all of my transformations, so to speak. And so now I'm ready to take a look at what this is going to look like on the graph. Okay. And the cool thing is right now, when there's a transformation, a lot of the times you don't have to make your XY chart. It's only when it's your parent function. So here's what I'm going to do. Here's my graph. And before I would have done anything, my parent function would have looked like this. It would have been going through 1, 0, and it would have been increasing, correct? So it would have been looking something like this, let's say. But since I have these two transformations to take into consideration, the new line that I'm going to have to go through is the point -2. So I will come over here to -2, and I'll make it blue. Now, remember, here's my y-axis. Since it was increasing, but I reflected it over the y-axis, what's it going to be doing now? Is it still going to look like this?
Yeah.
No. What's it going to look like now?
It's decreasing.
Yeah. Okay, and then so what's happening is, after all of this little blue line right here, this is my final answer.
So
And I'm done.
the line that you drew, it should be the original point 1, 0.
So this is what we call our parent function before we did any transformations to it. And then this line over here is my transformation line.
Okay.
And this will be the answer. I just put the black line on there to show you guys how the transformation is happening. So when you're doing transformations, I don't need, nor really do I want you to make an XY chart because it's too much work. Okay. So if you're doing a transformation problem, this is what I'd like to see you write out. Tell me where you're going to start. Tell me what the first transformation does. Where does that end that point? Say, okay, here's where I'm at now. Here's what's happening next. Bam. This is where I'm going to be. And then draw that point and say, okay, since there was a reflection, instead of increasing, now I'm decreasing, done. So it just takes a little bit of practice. Okay. But the thoughts behind it are kind of already in your mind because we've kind of been working on some of this. Okay. All right. What are your thoughts on that?
Good.
All right. Good. Okay. So now let's see. Chat's not bad. Okay. All right. So now what's going to happen is we talked about what a log is and we talked about how to graph it. And so what we're going to do next is we're actually going to evaluate some functions. Okay. And they're going to be maybe a little different than you've ever seen in your life, and that's okay. And so we are going to evaluate log expressions. I should have said that. Okay. And so we need to know a few things, 3 things that we need to know first. And these are going to help us. if we are given log base A of 1, that equals 0. And we are allowed to assume that and not have to show me the work because, B-E-C-A-U, because we know that A to the 0 is equal to 1. So let's say you're taking a test and you're given this function, and maybe this is a 10 down here, I don't know. You don't have to do any work. You can just say, oh, I know that A is, that the answer is going to be 0 because this is a true statement. No work needed. And so some of these things are going to let you just eliminate work, which is why I like them. All right, the second thing that we need to be aware of is if we have log base A of A, that equals 1. And we are allowed to assume this because A to the first power is just A. Right? So if I were to draw these arrows in, I would get, oh, look, A to the first power is A. Yep, that's true. And then the last thing that we need to know is that log base A of A to the X equals X, and A to the log base A of X equals X. Okay? Now, letter C is a little bit more rare, but we will see it. A and B we're going to use a lot. Okay? All right, so what we're going to do is we're going to be given an expression and we are going to evaluate for the right answer. And we're not going to use a calculator to do this. Okay, so I want you guys to bear with me and try to get in the habit of not always having to type things in, because specifically with logs, sometimes you can't. Okay, sometimes you have to, but sometimes you just can't. All right, so let's take a look. Okay, I have several examples. We'll only do a few if we feel.
Wait 1 second. Don't erase it yet.
Absolutely, yep.
Is that an A log?
Yeah, this is A, and then this is log base A equals A. Sorry.
So do we really only have, after this week is over, 2 weeks of class and then finals?
Yeah,
Can you rewrite that second part? So I don't know how to.
absolutely. I absolutely will. So let me try it again. So let's see. This is just A, and then the word log, and then another base A to the X. That's in the exponent form, and that equals X. Is that better?
Yes.
Okay. Yeah, Sarah, we just have this week, next week, and then 1 week of class, and then finals, and that's it. And I'm working on figuring out the final as far as the time and the date. I'll let you guys know that ASAP. All right, we ready to move on and try some examples?
Yes.
Do you have one more question?
Sure.
I should have asked at the beginning of class, but I forgot. So our exam next week, are we going to have 2 days to take it like we did the last one, or is it only on Friday?
I'm going to make it Thursday and Friday.
Okay.
Okay. All right, so here we go. So let's take a look at some expressions. So this is going to be example 10. You guys are going to catch on, super easy with this, and I think you're going to like it. So if I give you log base 5 of 25. Now, this is the problem they're going to give you, okay, in black. What I want you to add equals y. So when you look in Hawks, this is the only thing they're going to show you. But when you're writing it on your paper, all you're going to do is say equals y, because it has to equal something so we can solve it. And then once you get that done, you're going to draw your arrows just like we did way back at the beginning. And then you're going to say, oh, well, this means 5 to the, well, no, it doesn't. It means 5 to the y equals 25. And they're going to say, okay, well, 5 to the what equals 25. Done. 5 squared is 25. Done. This is a problem that we should be able to do with no calculator. Actually, all of the ones that we're doing right now, we should be able
Is
to.
that a Y?
Yeah.
Okay. So just Y equals 2?
Yeah. Right, because you're searching for the answer to this y. And we know that 5 squared is 25. Right?
Yeah.
All right, so then let's take another one. So what if I have log base 1/2 of 2? And again, that's all they're going to give you. I want you to put equals y. Okay? And then we're going to draw our lines just like we have been. And when we write it as an exponential function, we're going to get 1/2 to the y equals 2. And then we're going to say, okay, well, what does y equal? 1/2 to the what gives me 2. Basically, what I need to do is turn this fraction upside down. Well, when I have to turn a fraction upside down, what do I know about the exponent? It has to be negative. And if that were the case, I would instantly get 2 over 1. And so my answer for this guy is just -1. Okay, so we're digging deep. We're thinking about some things that we haven't thought about in a while. Okay, let's do one more. Okay, example 12. All right, now watch. This is just to show you that it doesn't matter, okay? What we're doing, the rules still apply. So what if we have log base pi of the square root of pi? Boy, this one looks rough, right? And again, you're going to add equals y so that you can draw your arrows. And then you will draw your arrows. And then what will happen is you'll get pi to the y equals the square root of pi. Well, when we did square roots way, way back, right, we technically know that there's a teeny tiny 2 on the outside, and we also know that this is just being raised to the first power. We transform this into x to the 1/2. Remember how we did that? So if we want to solve for this y value, I'm going to have to get rid of the square root. So pi to the y has to stay. But how can I rewrite the square root of pi so that the base is pi? This is going to turn into pi to the 1/2. And then we think back to Monday where we have the same bases. We have pi and pi. And when that's true, we just take the exponents, whatever they happen to be, and we set them equal to each other. And we will say that y equals 1/2. And now we're done. So take a look at these 3 and let me know, because I still have a few more that I want to look at. But you got to make sure that this is kind of clicking. You got to be like, oh yeah, okay, this isn't so bad. So what are your concerns with having done these 3?
The last one kind of confused me.
Yeah, same.
Is it because, okay, listen, is it because there was a pi in there, or is it because it was the square root?
I think
Square
it's just
root.
like the square root and how you got to the 1/2. Could you go over that one more time?
Absolutely.
Do it
So
without the pi.
yeah, I was gonna say, let me get one without the pi. Okay, so just hold on. This is just gonna be, this one's not in my notes. I'm making it up totally. So let's say that we have log base 3. Okay, the square root of 3. I guess that's what we'll do. Okay. Okay, and then that's what you're gonna be given, and you're gonna put equals y. Okay, and then you're gonna draw your arrows just like normal. And that's going to give me 3 to the y equals the square root of 3. So far, so good?
Yeah.
Okay, so now we're doing a little side note. Okay, we're pausing. A long time ago, okay, I told you guys, hey guys, do you know that when we study square roots, the square root itself is actually an exponent? You guys were like, no, we didn't know that. And I said, yeah. And I said, it really means x to the 1/2. And we went on to say that because we know it's x to the 1/2, if you look, let me get a different color here. When you look at just the square root of x, when we say square root, there's technically a 2 right here, but we don't ever verbalize, or we don't ever visualize that. We just say square. And when we say x, it's really being raised to the first power, but we don't have to say that because it's just a number. So we said that this guy and this guy were equivalent. They were the same. And then we went on to say, well, what if this was maybe a 3 and this was maybe a 5, let's say? Well, how does that change things? Let me make it a little bit darker. If this were a 3 and this were a 5, well, what would happen is the 5 would be out here and the 3 would be inside. Remember that at all?
I want to say yeah, but I honestly want to say no.
Okay, fair
I
enough.
remember.
Okay, so here's the thing.
I
Okay.
remember doing that when we did the inverse,
Mm,
right?
yeah, we did that because you're right. Because we gave you, I gave you a fraction or a square root rather. There's some stuff under and it was raised to like the 1/5 or something. Yeah, that's exactly right. So what we're going to have to do is we're going to have to somehow, you have a very short list of things that you must memorize. This is one of them. So no matter what this fraction looks like, whether it's bogus or whether it's a number, the bottom number goes out front, the top number goes in the inside, and vice versa. And so if you look at this, you say, hey, this is the square root of just 3 to the first power. So without having to do a ton of effort, or a ton of work rather, we're going to have to be able to look at this and say, oh, this is actually 3 to the 1/2. So what we're going to do is, so 3 to the y hasn't changed. The square root of 3, though, turns into 3 to the 1/2. And then I say, hey, look, I have the same base, which means y must equal 1/2. And now I'm done. So what I did with that pi, go ahead.
So whenever you see the square root, whatever you have under the radical, you just know that it's that to the 1/2.
Mm-hmm.
Okay.
So if you have a square root, y is always going to equal 1/2.
No. Okay, so watch. Let me add something in here in pink real quick. What if there was a 5 out here, and I'm just making this up. Let's say a 4 out here. Then what would happen is we would say, when I rewrote this, I would say that 3 to the y has to equal the 5th root of 3 to the 4th, which is fine, okay? But we would then know that this number's on the outside, this number's on the inside, so this is going to turn
3 to
into
4, 5.
exactly, yes. Okay, so just because we see a radical sign, we cannot always assume the answer is 1/2. What we can assume is that the outside number goes on the bottom and the inside number goes on the top.
Okay.
So anytime we see a radical, turn it into this because it's going to make it 1,000 times easier. Okay? Is that better, guys? I don't want
Yeah,
the
so
pie to
if there
split.
isn't numbers involved though, and it's just straight up the square root, it's the half. But if there
That is
is the
correct.
numbers, you can do that.
That is correct, yes.
Okay, I think.
Okay, awesome. All right, so let's get back on track here with number 13, and then I'll show you another form that we could see. So here's example 13. So what if I have log base 17 of 1? And again, we're going to put equals y because we don't know. And then we're going to draw our arrows, and we're going to say, oh, 17 to the y must equal 1. And this is one of the givens to us in our notes. Any number raised to this particular value gives me 1. What is that value?
0.
Yeah. So that was one of the A, B, or C. That was letter A. Okay, so let's take a look at one other one. I just have a few more, and then we'll move on to the next thing. But I got to make sure that this is making sense, okay? Not just, yeah, it's fine. So we're going to have log base 16 of 4. And we're going to put equals y, and we're going to draw our arrows. We're going to say, okay, that means 16 to the y has to equal 4. Well, I don't have the same base. And so we're going to think back to Monday when we said, 4 is good, right? 4 is a good base. Can I somehow take the number 16 and rewrite it as 4 to some number? Well,
Yeah, 4 squared.
exactly. So 16 becomes the number 4 squared. The y is still there. Anytime we have just a whole number and there's no variable present, it's just 1. And so that means that I'm going to take these two variables, or excuse me, these two exponents and set it equal to this exponent. So I'm going to have 2y equals 1, and I'm going to divide both sides by 2, and I'm going to get y is 1/2, and again, I'm done. Okay, and I have one more that I want to show you, and then we're going to actually solve some things, okay, because about where we have to do a little bit more work. So what are your thoughts on these two? Any issues, any problems?
Can you re-explain the second step to the last step?
Yeah, you kind of lost me there.
right,
The
let me-
2y business.
All right, let me back it up. Let me back it on up. Okay, so everyone's good to here, right? Where we got, where we have this, that's okay?
Yes.
Okay, so think back to Monday. We didn't have any of this. We only had problems that looked like this. And we were trying to make the bases the same. And we said, okay, this is a perfect square. Well, what's the square root of 16?
4
Yeah, and how many times 4 to the what gives me 16?
squared.
So this number 16 turns into 4 squared. Do we agree that 4 squared is 16?
Yes.
Yeah. Now, this y value is still hanging out. Well, if I have a base 4 here, I already have a base 4 here, so let me bring it down. And when I don't see any exponents up here, what is the exponent? It's just
1.
1. And so now the rules from the other day was once we have the same bases, we don't care about them anymore. We only care about the exponents. So what we're going to do is we get to say that 2y equals 1 because our bases are the same, so they don't matter. And then this is just divide by 2. Y is
Okay.
1/2.
Okay.
So we're just thinking back to what we did Monday. Okay? All right, I have one more like this, and then we're going to kick it up a notch and solve equations that look just a little bit different. Okay? All right, so here we go, 15. This section was kind of lengthy, if you haven't already noticed. So I had a lot of examples to show you. So log base 10 of 1 over 100. Okay, and that's what they're going to give you. You're going to put equals y. Then you're going to draw your arrows, and you're going to have 10 to the y equals 1 over 100. Okay, now, we know that we need the same base. We also know that the number 10, that's a pretty darn good base. So let's just leave 10y alone. Okay, there's nothing I can do to fix this guy up. Now, over here where I have 1 over 100, whenever you have a fraction, that tells you that the exponent is automatically going to be negative because you did have 100 and you flipped it, and so you made the exponent negative something. Okay, so that's a good assumption to make. So we know that we're looking for a negative number, but, and again, we're trying this without a calculator. So we need to know 10 to the what gives me 100. So this is equal to 1 over 10. Now, to something, to some power. If you don't know, we're going to count our zeros. How many zeros do I have right there?
2.
2. So this is really 1 over 10 squared. Well, if I need this 10 squared to pop up to the top, what do I have to do to this exponent? I have to turn it into a
-2.
negative. Yeah. And so the number 1 over 100 is actually equivalent to 10 to the negative 2. Now, do I have the same base?
Yeah.
Yeah.
You'll
So-
have when you're done, Catherine.
Hey guys, whoever's chatting it up back there, I need you to mute yourself for me. And so now we're able to say that, hey, look, this and this have to be equivalent. And it just so happens that I don't have to do any of the work. And y is -2. And now I'm done. So as far as taking a log function and evaluating it by putting this y value there and then drawing your lines and then calculating it methodically, what are your thoughts? 10 through 15. There were 6 examples for us to look at. All right, now what's going to happen is we're still solving log functions, but instead of there just being a nice, neat little base and a nice, neat little number right here, we're going to kick it up a notch, okay? So let's just, and there's no other notes I have to give you. It's just a matter of, take a look and see what you think. So here's number 16. And the problem is going to start out log base 6 of 2x minus 1. No, I'm sorry, 2x equals -1. So here's the problem. And the difference that you can notice is that this right here is no longer just a single number. Okay, so if you had to guess, obviously I need to solve. So I need x equals something. Well, what's my plan of attack? I've started as a log. What do you think I should turn this into?
An expo.
Yeah, and then once I have it as an expo, I'm going to solve. So it's a log now. I need to draw my arrows to get it to expo, and then I'll easily be able to solve it. So nothing has changed in the way that I do this. I'm going to start at the 6, draw my arrow to the -1, draw my arrow to the 2x. That's going to become 6 to the -1 equals 2x. Now, for the time being, once I turn it into an expo, don't care about this anymore. Right? Log's taken care of. Check. Now I'm on the expo stage. What are your thoughts so far? Because that's the most important thing you're going to do. Okay, so now we're trying to solve. Well, the first thing we got to figure out is what is 6 to the -1?
1/6.
1/6. Perfect. So 1/6 equals 2x. And now I'm going to divide both sides by 2. And so I'm going to get x equals, and in case we've forgotten, when we divide, we really flip and multiply. And so when I do that, I'm going to get 1/12. Now you could use your calculator for that, but I'm just showing you. So the answer to this problem is 1/12. So I got my expo, I solved. Now I'm totally, completely done. So from start to finish, what do you think?
Those aren't bad.
No, it's not bad. It just takes practice, right? It just takes a little bit of time. All right, so let's try another one, okay? So let's see, number 17. Let's do log base 2 of 8 to the x equals 5. And again, we started out as a log. We want expo, and then we'll solve it. And that's a v. Okay, so let's draw our arrows. So we start at 2, we head on over to 5, and then we come back and we hit 8 to the x. We say, okay, well, let's rewrite it. So we're going to have 2 to the 5th equals 8 to the x. Okay, now we're thinking back to Monday again, okay? We can't just set 5 equal to x because our bases are not the same. We've talked about how the number 2 is a solid base. I cannot change that. So my question is, can I somehow take the number 8 and turn it into base 2? In other words, 2 to the what gives me 8. Is that possible?
2 cubed.
2 cubed, yeah. And so what I'll do is I'll rewrite the number 8 as 2 cubed. Now it's still being raised to the x. And so now once I have the same bases, right, I'm allowed to say, hey, guess what? This guy is going to be equal to these guys. So I'm going to have 5 equals 3x. And then I'm just going to divide both sides by 3. And I'm going to get x equals 5/3. And now I'm done. Okay, what do you think about that one?
As long as you can remember everything that you have to do, I feel like they're not bad.
And that's why one of the reasons why I'm writing out the plan every time, because I feel like if I write the plan 1,000 times and you hear me say it and you hear me do it, that it'll stick in your brain. That's the goal. All right, let's do one more like this, okay? And then we'll move on to the last topic, which is common and natural log, which is going to be a breeze if you understand this stuff. All right, so let's do one more like this, okay? So number 18 is going to look just a wee bit different, but it's going to be similar, so don't scare yourself. All right, this is a normal 3, okay? Now I'm going to write the word log, but you're noticing I'm writing it small and I'm writing it above. So this little guy up here, hold on. This is log base 3x of 2. This whole thing right here, this is the exponent, the whole entire thing. And then I come back and I put a normal equal sign and a normal 2. Okay, so it's log raised to, or excuse me, it's 3 raised to the log base 3x of 2. The whole thing equals 2. Now, on this particular problem, as it's given to me, it turns out this is actually in exponential form because this guy right here is my exponent. So what I need to do is I need to rewrite this as a log because right now I can't do anything. And so then I'm going to rewrite it as a log and then I'll be able to solve. So this is my plan. So I'm going to draw my arrows just like I normally do, starting at my base, hitting this number and then hitting this number. But remember, expo gone, I need log. So I actually have to write the word log first. And my base is 3, so log base 3. And then I scooch over here and I say of 2, and then equals this guy, whatever it looks like. Don't care what it looks like. In this case, it's log base 3x of 2. So let me pause for a second and let you take that in. This was given to us as an exponential function already. I drew those arrows. I need it as a log function. So I literally wrote the word log. And then I said, okay, base 3 of 2 equals, and then now this is written normally. It's no longer a teeny tiny exponent because I brought it down. How did I get 3 log of 2? Okay, so let me back up for 1 sec, okay? Having some questions. So let me start this one again so that we can see it. Different color here. Do we all agree that the way that this particular problem is presented to us, it's written in exponential form? I don't see the word log anywhere except for in the exponent. Everyone agree to that? So I wrote over here that this is an exponential function. Well, I need to solve for x. Unfortunately for me, x is way up here. I can't solve for x unless it's in the normal problem, so to speak. So since this is an exponential function, I'm going to draw my lines just like I normally do. And so that's going to allow me to rewrite this as, and since I know I need log, I have to put the word log. My base that I started with is 3. My arrow scooches over here and gives me 2. I pass the equal sign, and this is my exponent, but it becomes a normal number. So what if, for just a second, what if, instead of having this, what if this was just a big old x? Wouldn't I rewrite this as log base 3 of 2 equals x? Isn't that the case? So just because this is nasty, it's still just, it's still just an exponent. All right, so let's take a look. Let me get rid of all of this. So does that clear it up a little bit better? Okay, so now here's what we're going to do. We're going to say, well, when we look at this thing, these two things have to be equivalent. Okay, they must be equivalent. The only difference that I see is this is 3x and this is just a 3. Do you agree that log and log are equal and of 2 are equal? So what that must absolutely mean is that 3 has to equal 3x because otherwise they wouldn't be equivalent. And the only thing I'm going to have to do in order for me to get x here is simply divide both sides by 3. And so now I'm done. X is just 1. So take a sec, think about it, ask me your questions, and if there are none, we will move on to the last topic, and it should only take about 10 minutes.
So if you see the starting base number, like the problem starts out as the number and not the log.
Correct.
That's expo form.
That is correct.
Okay.
And
so
99%
as long as you can know that.
Right. And so, and typically when we are solving, specifically when you see the word solve, if it gives it to us in exponential form, we typically want to change it to log. And if it gives us to us in log form, we typically want to change it to expo. So we're pretty much always going from where we started to the opposite. Then we're going to solve. And you're noticing as I'm writing the plan, I tell you where we start, I tell you where we go, and then I tell you to solve. Okay?
Okay, what if, see how the logs crossed out and the 2's crossed out because they were the same?
Uh-huh.
What if the 2's would have been like a 2 and a 5?
Okay, so
something.
like this, let's say. Let me do a different color. So
Yeah.
for our class, that's not going to happen.
Okay.
Okay. The way that these problems are designed is for you to just understand the basics. Okay. And so there's not going to come a time, if you're doing your arithmetic correctly, that this 5 is going to be a 5 and this is going to be a 2. They're going to be the same number. Okay. All right. So let's move on then to the last topic. Just 2 sentences and a couple of little examples, and then that's it. Okay. Depending on, if you have other questions. So here we go. Now, if you've worked with logs before, you know that there are 2 types of logs, so to speak. And the function, so if we have log base 10 of x, this is called the common log. It's called the common log. And usually it's just written as log x. Typically, we don't usually write base 10. Simply because it is known across the mathematical community that it is the common log. And so if you just see something that looks like this, log with no base written, you are to assume that it's base 10. And you are very much allowed to insert that 10. In fact, I encourage it because it's going to help us solve our problems much easier. Now, on the other hand, there's a second type of log, which my guess is maybe you've never seen this. I don't know. If we have log base e to the x, and remember from the other day, the letter E is a button on your calculator, right? It doesn't necessarily mean a variable. It's not a variable. It's an actual number on your calculator. So if we see something that looks like this, log base E of x, this is called the natural log. And that is typically written as the ln of x. This is a cursive L. And the reason why I don't just write a lowercase l is because doesn't that look like the number 1? Yeah. And so when you write the ln, this is just a cursive L. Some people like to write the capital L. I'm okay with that. But my personal preference, for some reason, I guess it's because I like logs, I enjoy writing that cursive L, okay? So it's typically written as the ln of x, and it's read the ln of x, okay? Now, here's the thing. When we're doing these types of problems that we're about to look at, most of the time, this guy here and this guy here, you're going to kind of be able to tell when you should use which, okay? Now, it takes practice, but you're going to be able to pick. And so the next couple of examples that we're going to look at, we're going to have to say, okay, based on this, should I use should I use the common log, which is log base 10, or should I use the natural log, which is log base e? And I know you're thinking, what the heck is the difference? Okay, I'll show you. Each of them have a different purpose, but they work the same, which means their rules are the same, okay? So let me show you an example first before you start calling me crazy, okay? Because I know without looking at something, it doesn't make any sense. So here's example 19, okay? So let's say I give you this problem. Let's say I give you the ln, and then you see the cube root of e. And I say to you, okay, buddy, I need you to just go ahead and solve this for me. I need an answer. What would you do? Cry? All right, so what do you think? Well, okay, hold on. Someone's chiming in. Let's see what they say. Yes, okay, she would cry. I'm sorry, I don't want to make anybody cry. Okay, so here's what we're going to do. Okay, according to the previous page, when we see, I'm just going to jot this down so that we can see it. When we see just log of x, we know that's actually log base 10. And when we see the ln of x, we know that's actually log base e, okay? And so what's going to happen is when we are presented with this ln, most of the time when we're given an ln, there's also an e in the problem. Okay, that's kind of like its little telltale sign. And so when we're given the ln, what we want to do is we want to rewrite the ln as log base e, because that's what the ln is equal to. And then we're going to go on and we're going to say, okay, well, we've taken care of this, so to speak. Now we know that we are left with the cube root of e. We also know that the letter e is just a constant, so we don't care about it. We don't care about e, so to speak. But I do care about this cube root. I can't just have the cube root. So think back to like 5 minutes ago when we had the radicals. This is going to become e to the what? What number is on the inside? A 1. Whoops, a 1. What number is on the outside? A 3. And so this whole monstrosity is going to turn into e to the 1/3. Do we agree to that, first of all?
So it would just write log e to the 1/3.
Almost. Don't forget about your base e, right? Because we took ln and we turned it into log base e, and then we've taken care of this guy, and it's, now this e that I'm about to draw is normal. It's just a normal e, and that's to the 1/3 power. Okay, now what we get to do, I know this is weird and confusing, okay? We get to forget about all of this now, because right here's where we are. We've written this as a log function. Okay, just a moment ago, I said if we're given it as a log, we want to turn it into an expo, and then we want to solve. And so in order for us to turn this into an exponential function, we have to insert the equals y. And then we have to draw our arrows. This is from e. And so when I do that, this will become e to the y equals e to the 1/3. And I don't really care that the base is an e. That could have been a 2 for all I care. What I care about is that they are the same. And so now I'm able to say, oh, y equals 1/3. And that's what I need. And now I'm totally and completely done. So let me erase some of this stuff and let you kind of ponder back on what we did. Let's see, get rid of that, get rid of this. So you can see where we started, and you can see the work that we did, and you can see where we ended. Now this takes practice, and I have a couple more, but I just want to make sure that this kind of makes sense. So what are your thoughts? And again, we didn't use a calculator. We did not use a calculator on this one. So this is a good no calc problem. Okay, what do you think? The processes, does the process, kind of make sense?
Yeah.
Okay, so we'll practice, okay? But I need to know that if the process, you're not just like, man, you just pulling this out of left field. Okay, the process makes sense, so that's good. Right now, let me show you one where, and I'm finally going to tell you, you're going to have to use a calculator, but I want to show you the difference. So let's say that you're given the ln of 4.78. Well, one rule of thumb, so to speak, that you're allowed to assume, because I'm telling you, is when you typically, if all you have is the word log or the ln out here, and all you have inside is a number, but it's a decimal, that automatically screams calculator. So you're going to get your calculator out, okay, if you have it. And somewhere on your calculator, you have a button that says log, and then right below it, it says ln. Do you see those buttons?
Yeah.
You're going to hit the ln button, and then what's going to pop up is lowercase l, lowercase n, parenthesis. You're going to type 4.78, close parenthesis. You're going to hit enter, and you're going to round that son of a gun off to, I don't know, 3 decimal places, let's say. And this is going to be the easy problem, so don't overthink it, guys, okay? Literally just type this in. So what is the ln of 4.78?
1.564.
Perfect. Now see, watch. Let's pretend for just a second that you're like, man, I didn't know I could use my calculator. Because sometimes I've been pounding, don't use your calculator. Here's what's going to happen. You would have rewritten this as log base c of 4.78, and that would have equaled y. And then you would have rewritten this, look like this, and you would have e to the y equals 4.78, and you say, well, my gosh, I don't know. And when you hit that my gosh, I don't know moment, that's when you're like, oh, probably should have just typed it in. So this is absolutely a calc problem. What are your thoughts on 20?
I mean, that one was simple.
Exactly, right? So let's take a look then. We talked about the natural log. Let's take a look at what happens if you're given a problem that uses the common log. So let's say this is what you're given. You are given log of 10,000. No, I'm kidding. You're given log of 1,000, and that's it. And I say to you, I need you to solve this. Well, the first thing we're going to do is we're going to say, look, what's the base down here? I don't see a number. So when I don't see a number, what do I have to assume the base is? 10. That's given to us in the page of notes beforehand. Well, I also don't see equals y, so I have to put that there. And now I'm ready to draw my arrows. And so this turns into 10 to the y equals 1,000. And remember, you don't have a calculator for this one. And you're thinking, oh my gosh, I don't know. Count your zeros. How many zeros do you see over here in the number 1,000?
8.
And so y is 3. And so 10 to the third is 1,000, and now you're done. So when you have the common log and there's no base given to you at all, you assume and you can insert the number 10 every time. Now, let's say we'll do example 22 on the same exact page. What if you're given log of 10.5? And I say, hey, solve this. Well, look, there's a decimal only. Calculator. So on that calculator, you're going to hit the log button. So log will come up. They're going to be lowercase, though. And then, of course, a parenthesis, and you're going to type in 10.5, close parenthesis, enter. And when you do that, you're going to get 1.021, and then you're done.
Isn't it on example 21, you can put it in your calculator as log 1002? Because I did it, and I put log 1000, close my parenthesis, and I got 3.
Okay, so here's my question for you. You're right, but I hesitate to say that, okay? Watch this for just a sec, okay? I'm going to come over here. You typed in log 1000, and you got the answer 3, and that was wonderful, okay? But what if the problem said log base 7 of 1000, let's say? Can you type this into your calculator?
No.
No. Okay. So what I'm trying to do is I'm trying to teach you how to do this without the calculator, because when you hit the log button on your calculator, it is assuming base 10. And you can't turn that 10 into a 7. And when you hit the ln button on your calculator, it is assuming log base e. Okay, so that's why we can only use the ln button or the log button if it is log base 10 or if it is log base e. So we can't just make that 10 magically become a 7. Okay, so you're right, Sarah, for this particular problem, but not every single one. Okay. All right, so here's what's going to happen. Okay, we have two or three, depending on what you feel, examples to go. And these are going to be problems that we're kicking it up a notch, and we're not just going to, it's not going to be as simple as those 2 that we just looked at. Okay, so watch. We're going to have the ln of 7x plus 2 equals 5. And I say, okay, guys, go ahead and just solve this for me. Okay, well, a couple of things. Which way is it given to us? Is this a log or is this an expo?
Log.
Yeah, because you see ln, right? So that means log. And so since it's given to us as a log, we want to turn it in to expo. Well, I can't draw those arrows unless I have a base, which right now I don't visibly see a base, right? I need to actually see a base before I can draw an arrow. Well, that's okay, because I know that when I am given the ln, what is that really saying? It's really saying log base what? Yeah, and so now this is gone. And this part hasn't changed. So 7x plus 2 equals 5. Okay, now I have a base. Okay, and I can start at that base and I can draw my arrows. And so when I do that, I'm going to get e to the 5th equals 7x plus 2. Now remember, this letter E, it's just a button on your calculator. So we're not going to hit it just yet, because if you type e to the 5th enter, you're going to get some terrible decimal. Now, out of all of this, so we went from log to expo, check. Now we have to solve. And I need x equals. And so if I look for x, it is stuck right here. And so we're going to forget the whole idea that we're doing logs, and we're going to say, okay, think way back to like day 1. How do you solve this for x? What do I need to do?
Subtract 2.
Okay, so I do that to both sides. So that's going to give me e to the 5th minus 2 equals 7x. Okay, well, x is still right here. So what do I have to do?
Divide by 7.
So what's going to happen is, let me get rid of some of this stuff because I'm running out of space. So when I do that, I'm going to end up with something real big and nasty, which is fine. Okay, so I'm going to get x equals e to the 5th minus 2 whole thing over 7. Now in Hawks, they're going to ask you for an exact answer. And you're going to say, okay, there's my exact answer. That wasn't so bad. And then they're going to ask you for a decimal approximation. Okay. Now, if you have your calculator, here's how you're going to type this in. You do not want to type this in all together. You want to do e to the 5th first. And so e, and you're going to hit that little caret button or whatever the button is that lets you go up. I can't remember. Everyone's is different. Then you're going to hit the minus 2. Then you're going to hit enter. Then, before you do anything else, don't care what that number looks like, you're going to do divide by 7. And then you're going to hit enter again. So the answer that you should get when you do this is approximately 20.92. So take a sec, practice typing this in, make sure you get 20.92 because you have to be able to type these in. Anybody having issues with this?
I didn't get it.
Okay. Okay, let me pause for 1 second because I want to erase some. Before I erase any of this stuff, are there any questions on how I got from where I started to right here? Because of course, this is the chunk of work that I did. Any issues with that? Turn it into log base e, turn it into an exponential function, solve for x like I know how, and I'm right here. Any problems? Okay, so then Taylor, you have like the TI 30 something calculators, like blue or something like that?
Yeah.
Okay, so you're gonna type, I think it's your second button,
Uh-huh.
then your
Yeah,
LN
I
button.
got it.
Okay, so then E is gonna come up, and there's gonna be like a little thing like this, or maybe there's a parenthesis. I don't remember.
It's
gonna
both,
hit-
yeah.
You're gonna hit. There's both.
Yeah.
Okay, you're gonna hit the number 5. You're gonna close that parenthesis. You're gonna hit your arrow right button, and then you're gonna type -2.
Okay.
Then you're gonna hit enter, because what I think was happening is you were probably typing the -2 with the 5. Once you get that number, which again is going to be a dirty decimal, you're just going to hit divide by 7, and then you're going to hit enter again. And this is what
Okay, I got it.
You got it? Okay, anybody
Yep.
else having an issue getting that?
I got the same answer, and I didn't have to hit the right arrow.
Okay, that's fine. Even though you might have the same calculator, sometimes the modes are set up differently. So whatever works for your individual calculator is what we're going to go with. Okay? And so now we have our decimal approximation. We type that in Hawks. We're done. What do you think? That wasn't so bad, right? It takes practice. Practice. All right, I promise you 2 more, and then I will shut up, okay? Because I've been rambling a lot today. All right, so let's take a look. 24. And this one, we're going to have log base 81 of x equals 3/4. So, and again, I'm saying, hey, I need you to solve this. Well, first things first, how are they giving me this?
Log form.
So what do I want to turn it into?
Expo.
Perfect. And so I'll draw my, I go to draw my arrows, and hey, look, I already have a base, so that's good. So then I will start here, and I will draw my arrows just like you said. And when I do that, I'm going to get 81 to the 3/4 equals x. Well, what do you think you can do with this little guy? I gave you one similar to this, and I graciously let you use your calculators. So let's get that calculator out, okay? And so you're going to type the number 81, and then your caret button or whatever the case might be, and then a parenthesis probably pops up, and you're going to do 3 divided by 4. You're going to close that parenthesis, and then you're going to hit enter. And what you should get when you do that is the number 27. So let's make sure that you can type that in the right way. So 81 raised to the 3 divided by 4, enter. X is 27. Any issues, any problems with that? When you're working in your Hawks, the questions, they're going to specifically say, do this without a calculator. Those are the types that I absolutely need you to be able to do. If it doesn't say, don't use a calculator, then you can type this in, okay? And this would be a problem where I would expect that you were to use your calculator. All right, 1 more to go. Any questions on 24 before we finish this up? I thank you guys for staying with me so long. I really appreciate it. It's really helpful. All right, so here we go. Last one for the day. Example 25. And I apologize, but this lesson was very lengthy. So we have log base 2 of 2x minus 2, and that is equal to the number 4. And again, I'm saying, hey, solve this. And so we look at this and we say, okay, which way is this given to me?
Log form.
So I need to turn it into expo. And so I go to do that, and I say, oh, hey, look, I already have a base, so I'm good. And so I draw my arrows, and then I say 2 to the 4th equals 2x minus 2. Now I get to forget about this guy, right? I'm just solving an equation. Well, 2 to the 4th turns out to be 16. And so 2x minus 2 is going to stay the same. And just like normal, I add 2 to both sides. And then I divide by 2. And x is 9, and now I'm done. That was the sound of me throwing my pen down. All right, what do you think about this one, number 25?
That one was easy.
Yeah, that was easy. So again, when you're stressing out about calculator versus non-calculator, the directions are going to tell you. And I know, believe me, I know that it's tempting to use a calculator, right? Because why not? How am I ever going to know? And by no means am I saying that's okay. Okay, I'm just saying what I believe. But what I need you to understand, okay, and I really need you to understand this, is that it's important. It's very important that you can do some of these problems. Hold on, I've hit the wrong button, and now I can't see anything. Where am I at? Can you guys see anything? Ah, there we
I
go.
see your desktop.
Yeah.
See your
I'm on
desktop.
Oh man. Okay, well, I've done something real dumb and now I can't see anything. So I can't even turn my video on. Oh yes, I can. Okay. All right. So what are your thoughts overall about this? Because I'm done as far as notes go. So you got to tell me what you think.
It was a lot, but as long as someone said that we just remember the steps and know what to do, when to do it, then we'll be. It takes practice.
It takes practice, right? And so what I've done is I've uploaded these notes, okay, just in case. I have also uploaded. Can you guys still see my screen or just my face?
Just your face.
Oh,
The
great.
whiteboard thing went away.
Okay, well I'm done.
Yeah, just your face and like the Zoom thing.
Okay. If you look in Blackboard, in the folder of 7.3, which is today, I uploaded the 7.3 Hawks video, which is just kind of an explanation of the topic. There's the 7.3 My Notes. There's 7.3 Practice Problem video, which I made and uploaded. And then below it with green writing is a second set of practice problems, but I didn't turn into a video. It's just the work. So I have tried really hard to give you so many examples of these types of problems so that you have something to look at, okay? I also created the 7374 worksheet, and I put on there, if you were to look at it, I think it was like number 1 through 8 was from 7.3, and I put in there in big red writing, I said, guys, you must know how to do this, okay? And I'm not trying to be a jerk, or I'm just prepping you for the test because I know what's coming, okay? Believe me, I know what's going to come, so I'm trying to get you there, okay? I know this is an interesting semester to say the least, so I'm trying to get you where I need you to be. So anybody have anything else they need to say or ask me before we call it a day? Because I'm done. If you guys need something, let me know.
When
Is
is
it-
the 7.1, 7.2 support due?
Let's see.
Thursday.
Yeah, tomorrow night
Tomorrow.
at 11:59 p.m. Yes.
Okay.
Is that it? Okay. What
Have
else?
you heard anything? I've heard rumors about Fairmont's discussing having their fall classes online again too.
Oh no.
Listen, I've heard those rumors too, but I have heard nothing official. And you know how rumors are, guys. So don't hold your breath. Don't hope for it. Don't think it's happening until we hear something, because I have no idea.
I know all
Okay.
their summer classes are online, but
Yeah.
I think that's normal, isn't it?
Yeah.
No, not necessarily.
Not every time.
Yeah, because I always teach in the summer, and my class is always on campus because I like that. Again, I told you guys I'm not an online teacher. I don't love it, but I went ahead and said, yeah, I'll teach mine online because there's no way we're going back for the summer.
I'm about to be a junior, and I thought that summer classes were always just online.
No. So I'm just kind of, if I hear anything, I'm sure you guys will get the same email I get. Believe me, I am nobody's special person. They say, hey, here's what I heard. So don't think that. But yeah, that's all I know.
Do you think if that was the case,